So we've talked about how important backups are and why you should be backing up any important data and some tools that can use to help you back up data. But how exactly do you decide when and how to back up data? Well, let's explore those options. There's a couple of ways to perform regular backups on data that's constantly changing. You can do a full backup on a regular basis, which involves making a copy of the data to be fully backed up. The full unmodified contents of all files to be backed up is included in this backup mechanism, whether the data was modified or not. In the case of data that doesn't change very often, like operating system configuration files, this approach can be inefficient. You're backing up multiple copies of data that isn't changing, which wastes space and uses bandwidth unnecessarily. That doesn't seem like the best idea, does it? A more efficient approach is to only back up files that have changed or been created since the last full backup. This is called a differential backup. The advantage is that you aren't storing backups of duplicated, unchanging data. Only the files that changed are backed up, saving us some storage space and time to perform the backup. But you wouldn't want to completely stop taking full backups. Over time, you'll wind up tracking and storing lots of copies of files that change a lot, which will also take up more and more disk space over time. To avoid this, it's a good practice to perform infrequent full backups while also doing more frequent differential backups. How often you perform a full backup will depend on how far back you want changes to be tracked. Let's say we perform full backups once every week and differential backups daily. In the worst case scenario, we'll lose close to 24 hours of data changes. That's not bad. Another efficient way to back up changing data is to perform regular incremental backups. While a differential backup backs files that have been changed or created, an incremental backup is when only the data that's changed in files is backed up. This is even more efficient in terms of both disk space and time required compared to differential backups. Again, you'll want to use frequent incremental backups along with less frequent full backups. But because this approach only stores differences in the files that have changed since the last incremental backup, it's possible that all incremental backups are needed to fully reconstruct the files. If one of these incremental backups is missing or corrupt, it might not be possible to recover data any more recently than the last full backup. Another drawback is that recovery might be more time-consuming. This is because the most recent version of backed up data has to be recreated by integrating the last full backup with each incremental backup that follows. For super large files that are changing frequently, this could require a lot of time to process. One more thing backup systems can do to help save space is file compression. When creating a backup, all the files and folder structures will be copied and put into an archive. Archives are useful for keeping files organized and preserving folder structure. Besides archiving the files, backups can also be compressed. This is a mechanism of storing the same data while requiring less disk space by using complex algorithms. Those are way too complicated to go into detail here, but it's important to call out that not all data types lend themselves to being compressed. This means that space savings from compression will depend on what you're backing up. Another thing you should know about compressing backups is the expense of restoration. To recover data from a backup, it needs to be decompressed first. Depending on the size of your backups, this could take a lot of time and disk space to expand. We touched on backup storage location a bit in the last lesson, but let's dive into a little more detail. Good news, there's a pretty cheap and easy to maintain option out there for storing backup data on site. You can use a commercial NAS device or configure a file server with a large amount of disk space. Wherever you choose to store your backup data, you'll need a lot of space. You could go out and buy a giant 10 terabyte hard disk, which could work for a little while, but what do you do once your backup data grows to fill that one disk? Are they even making disks larger than 10 terabytes yet? Another thing to worry about is what you do if that one disk holding all your backed up data fails. Yikes, that wouldn't be good. These are issues a RAID array can address. RAID stands for Redundant Array of Independent Disks. It's a method of taking multiple physical disks and combining them into one large virtual disk. There are lots of types of RAID configuration called levels. Depending on the characteristics desired from the array, various RAID levels prioritize features like performance, capacity, or reliability. RAID arrays are a great, inexpensive way of creating a lot of data capacity while minimizing risk of data loss in the event of disk failure. They can even be flexible enough to allow future growth in disk capacity. We won't go into the nitty-gritty details of the different RAID levels available, but if you want to learn more, check out the supplemental readings at the end of this lesson. I want to stress the fact that RAID isn't a backup solution, it's a data storage solution that has some hardware failure redundancy available in some of the RAID levels. But storing data on a RAID array doesn't protect against accidentally deleting files or malware corrupting your data. This is so important that I'm going to say it one more time. RAID is not a replacement for backups.